Alright, so the next problem we're going to be solving is LeetCode hard, problem number 1368, which is minimum cost to make at least one valid path in a grid, right? So we're given an n cross n grid. Each cell of the grid has a sign pointing to the next cell that you should visit if you are currently in this cell. The sign of grid I of j can be 1, which means go to the cell to the right, that is go from grid of ij to grid of ij plus 1. 2, which means to left, grid of ij, grid of 2, grid of ij minus 1. 3 is go to the lower cell, that is downward, grid of ij to grid of I plus 1 comma j, and 4 means that going to the upper cell, that is up, grid of ij to grid I minus 1 comma j. So notice that there could be some signs that point outside the grid, so we have to check that validity for being within the bounds as well. So you will initially start at the upper left cell, that is 0 comma 0. A valid path in the grid is a path that starts from the upper left cell 0 comma 0 and ends at the bottom right cell m minus 1 comma minus 1. Following the signs on the grid, the valid path does not have to be the shortest. That is also a very key, very important thing in the problem. Then you can modify the sign on a cell with cost equal to 1. You can modify the sign on a cell at one time only. So return are basically aim is to return the minimum cost to make the grid have at least one valid path. So for example, in this problem, we have been given 1, 1, 1, which means that we have to go right, right, right in the first row. And in the second row, we have 2, 2, 2, 2, which means we have to go towards the left, and again right, and then left. So these are the arrows that have been placed over the grid. So let me show you. What we can do to get the minimum path is that we are standing here 0 comma 0. So we'll go here because these arrows are pointing towards the right itself, so there's no cost involved. So we can go. We don't have to change the arrow. So till now cost is 0. But now you see this arrow is towards the left, but we need the arrow to be towards down, right? Since we have to traverse to the bottom bottom right element, which is m minus 1 comma n minus 1. So here the cost would be equal to 1, right? Since we have changed this one. Again, we need to change this one to downward. So again, the cost would be added, that is equal to plus 1. And then finally, again, the cost would be, sorry, this one would also be included, since this has to be converted to down as well. Finally, when we reach here, you see that these 3 arrows have been converted to the down arrow. So the cost would be equal to 3. This arrow would not matter because the arrow at the final position, it does not matter because we just need to reach towards the last cell, not manipulate the arrow present here. So therefore the cost is 3, as you can see in the answer also it's given. So you can read through this, that is the same explanation that I have given. Similarly, in this question, you can see if we follow this path that is going towards the right, then go down, then go left, then again go down, then go right, you reach the final bottom right cell. So you see that there was no requirement of changing any arrows, therefore the cost is equal to 0. So we can follow the path. And the most important thing is that since we do not need to make the path which is valid to be the shortest, since that is not a constraint added, then we can basically move with the longest path also to get to this, just to minimize our cost, right? So the cost is minimum here, so that's all we need. Now for this example, you can see we would require to change either this arrow towards the down, or either that is the only option, this arrow to the down. To convert it to down, we require one cost. Then there's another option, if you might have been thinking that we can convert this arrow to down, so that would require cost 1, and then this one also we have to convert to towards the right, so that would be a cost of 2, which is more than the minimum cost that we have seen. So that is why we choose this option, that is to convert this one to the down arrow. So this is the brief explanation of the problem. So let us start thinking how to go about it. So the first approach that comes to my mind is Dijkstra's algorithm. So the intuition, let me share with you what I'm thinking. So we start thinking of the grid as a network of connected points, that is a graph. So each cell represents a point, which is a node, and the cells are connected to their neighbors. So for example, this is the grid, right? Let us say this is the grid. Let us just say this is a 2 cross 2 grid. So let us think of it in this format, that each cell is a node, right? And they have been connected with these edges, right? So we're thinking in terms of a graph, and the edges have costs. So the cost, that it could be a binary, it is a binary choice that we have, that is cost would be 0 if the sign in the cell points directly toward the neighbor, and cost would be 1 in all the cases where we have to change the sign from, let us say, down to right. So this basically gives us the problem where we need to find the cheapest path or the minimum cost to reach a particular node through a directed graph. Therefore we are going to be using Dijkstra's algorithm. So that's the intuition behind the problem. Now with Dijkstra's algorithm, we basically use a priority queue, you remember, to explore cells based on their current cost, ensuring that we always process the lowest cost path first. And we also maintain a grid that is minimum cost, where each cell would track the minimum or the cheapest way to reach the cell from the start. Now the priority queue would hold cells we are currently exploring, each entry containing 3 pieces of information, that is the total cost so far, the total cost along with the I and j values, that is the x and y coordinates, right? So these would be stored in the priority queue, right? So these are the indices, that is the cell indices and the total cost till now. So the queue is organized as the cells with the lower cost are processed first. That is why we are using a minimum heap, right? Which helps us prioritize the least cost paths more over the expensive ones, right? So that's another thing. And For each cell we explore, we have to evaluate all of its neighboring cells. So we have 4 directions that we can go to. So we calculate the cost to reach the neighbor by adding the current cost to the cost of moving to the neighbor. That is, it could be either 0 or 1, as I had explained, depending on the direction of the sign. And if this new cost that we have gotten is lower than the current recorded cost in minimum cost, then we update it. So minimum cost would be updated, and we add the neighbor to the queue. That is, we push it, and then we go over to exploring further, right? So this process basically continues till the time all the cells have been explored and the priority queue is empty. And at this point, the minimum cost would hold the minimum cost to reach each cell from the starting cell, which is at the top left corner, right? And basically, the minimum cost would be stored in the bottom right corner of the grid. So now moving on to basically what we're going to be doing in the algorithm. So firstly, we're going to uh, initialize a 2D array directions with 4 direction vectors. So let me just do that. That is uh, vector of int directions, which would store our all the 4 directions that we can go over to. So firstly, we have the direction for left, right. Uh, Sorry, this would be basically in the in the y coordinate. We're going to be moving up. So this is for up. Then we have for down. Then we have for going towards, basically x has increased, right? Sorry, this would be towards right. This would be left. Then this is down, and this is -1, 0 is basically moving one cell right in the direction up. Okay, now we're going to be declaring firstly the number of rows, that is m is grid dot size. So this is the number of rows, and then we have the number of columns, that is grid of 0 dot size. So n is the number of columns. Then let us create a priority queue. So it would be a minimum heap because we have to store the minimum cost. So we are going to be making a priority queue which would store 3 things. Let me just initialize this. So vector of int, then we have vector of int, and we have greater, right? So this is the initialization for the priority queue, and this would essentially store our 3 things, that is the cost and the row as well as the column, so x and y coordinates, right? So once we've done this, we push the initial values, that is the cost right now is 0 since we're standing at 0, 0 coordinate, that is the top left cell. So after pushing this, we basically need to, in order to track the minimum cost for each cell, we basically minimum cost to reach each cell, we basically create a minimum cost grid vector of int type minimum cost, which would have m number of rows and vector uh, and the number of columns here, and int max. We initialize it with int max, which is in uh, basically storing, since we're going to be storing the minimum cost, we first initialize it with the maximum values, right? And min cost of 0, 0, basically storing the top left cell as 0 because the cost to reach that cell is 0 essentially because we're standing at that cell, right? That is the starting point. So that cost will be 0. Now we start our algorithm that while our priority queue is not empty. So this is basically the Dijkstra's algorithm. So while the priority queue is not empty, we basically get the current element from this. So pq.top, and then pop it out. Once we've done that, we basically uh, get the cost, that is int cost is equal to current of 0. Then similarly, we have 2 more values, that is current of 1 and current 2. X, this would be x, and this would be y. Wait a second, this would be y. So now we first check if the minimum uh, cost of row column is not equal to cost. We'll continue. What this means is that if in case uh, we've found a better path to the cell, then we skip it. If there's a better path existing, then we don't want to visit it again, right? Now 4 directions we can visit. So the standard function, that is for auto d belonging to directions, int x, nx, that is the next cell, x coordinate would be x plus d of 0, and similarly ny would be the next cell's y coordinate that we're visiting, right? So we check firstly if it is valid. So if inbounds, we first check that, and the if inbounds, so if is valid, so we'll have to make another function, that is if is valid. We check for nx, ny, and m and n are the number of rows and columns respectively. So let me create this function is valid quickly for you, so that would be easier for us to check it. So bool is valid, int I comma j, then number of rows and the number of columns respectively. So we have to return that, return if in case I greater than equal to 0 and j greater than equal to 0 and I less than m and j less than n. So we basically return true if these conditions are met, if they are in bounds, otherwise we return false. So if is valid, we check it, we check the validity that if the coordinates nx and y are in bounds, then we add cost equal to 1 only uh, in case we have to change, in case we have to change the direction of the arrow, right? Change the direction of the arrow. So int new cost is equal to cost. Now comes the important part, that is if the direction, that is uh, how do I explain this? If the d value that is not equal to our grid of row column minus 1. So basically we have to return either 1 or 0, right? So let me just change these values a bit, or change this a bit in order to get it into a more readable format. So int direction is equal to 0, direction less than 4, direction plus plus. So if the directions, if the directions uh, direction, right? So I'm just basically extracting the direction value easily from here. So if because there are 4 values given to us, right? That is 1 2 3 4, right? So that is from this we'll get the direction. So since we have the direction values going from 0 to 3, we can basically get the direction, and we check if in case the direction isn't equal to the grid of uh, row column, which would be x comma y, that was the previous cell, minus 1. Why am I doing minus 1? Because the grid's values have been given as 1 2 3 and 4, and the direction here is going from 0 to 3. So this is 0 to 3 and this is 1 to 4. So to get that into the range, we have subtracted 1. So in case this is not happening, then we basically this needs to be in braces, and in case the direction is not equal, then the cost would be added as 1, right? Then the cost would be added as 1. Otherwise, if the direction is equal, then the cost would be added as 0. There would be no cost. So this is how I've written this expression. This is important, right? So after that, we if we update if we found a better path, update if we got a better path, right? So if the minimum cost that we have gotten, minimum cost of nx and ny, that is the next column, next row and column, is greater than the new cost that we just wrote down, then we update the new cost, update this one, minimum cost of nx and y as the new cost, and then we push this new cost along with the uh, next cell's coordinates nx and ny, and finally we return the final value which we'll get in the grid, the grid's bottom right element, that is min cost of m minus 1 and n minus 1, and then we run this. So we're getting an error, that is min cost, okay, min cost, okay, min cost, right? So this is the vector of vector type min cost that will store our final answer, and row and column, sorry, row and it's actually x and y. So x and y, if the min cost of x and y is not equal to cost, if we found a better path, then we skip it. Again, we have another problem here. This is new cost, not next cost. So if min cost is greater than new cost, then we update it and we finally get our answer. Yeah, so it has been accepted, and I hope you understood this problem. How do we solve it using Dijkstra's? And yeah, that's it about the problem.